New Orleans, I don't expect to find such a multi-million-dollar cutting-edge research facility as this. And yet, this is the place where recently one of the most important scientific discoveries in human history was made. This is LIGO.
The Laser Interferometer Gravitational Wave Observatory is an enormous construction shaped like an L, with a sophisticated laser system bouncing up and down the two arms.
So we're standing on top of one of LIGO's two arms. This is the first LIGO arm. And in that tube, there's a laser beam that we bounce back and forth between a mirror in the end station and a mirror in this building. And the other bit goes that way, 4 kilometers, perpendicular to the arm we first saw.
This is the L shape.
It's a big L on the ground. So the light bounces back and forth in that arm and bounces back and forth in this arm. And what we actually measure with LIGO is the length of this arm as measured by the light between the two mirrors, and the length of that arm as measured by the light between two mirrors. And then the laser interferometer measures the difference between those two arm lengths.
So as the gravitational wave passed through, the lasers picked it up. They detected that LIGO's two arms changed in length to a very, very tiny degree.
The signal that we saw was just a few thousandth of the size of the atomic nucleus. It's the biggest the signal ever got.
So far, far smaller than the size of a single atom.
Oh, much, much smaller, yeah, that would.
And you need something this huge to pick that up.
That's right. And so this is one of the biggest source of energy in the universe, one of the biggest events you'd ever measure, and we just barely saw